Hello friends, welcome back to another video lecture of ADA subject. In this video lecture we are going to learn about topological sort. So let's start. So topological sort can be obtained by two methods. First one is DFS based and second one is source removal based. So first of all, DFS based algorithm in topological sort is a process of assigning a linear ordering to the vertices of DAG, means directed acyclic graph. So all of we know that what is directed graph and what is acyclic graph. Here we have examples. Here we have this graph that is directed. We can know with this arrowhead that is directions are available in our graph from one node to another, or we can say one vertex to another vertex, so that is directed graph. But with that we have to check that that is acyclic also. For example, here we have paths from 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to again 1. So this is a cycle is occurred in our graph. Here again we can check from 2 to 3, 3 to 4 and 4 to 2. So here again a cycle is occurred here. So this is cyclic graph. But we can have a cyclic graph also. Here in this example we can go to 1 to 2, 2 to 3, 3 to 4, 4 to 5, but we cannot go from 5 to anywhere. Here again 1 to 2, 2 to 3, 1 to 2, 2 to 4. So no cycle is happening here. So this is a cyclic graph. So our definition says your DAG means directed acyclic graph. So this graph is directed and also it is acyclic. So for this type of graph, there is an edge from vertex I to vertex J, then I appears before J in linear ordering. So we have to order all the vertices into a sorted manner. That will be based on DFS. Okay, so here one note is given here. DFS based algorithm graph must be directed acyclic graph. DAG means this type of graph is compulsory for our sorting. So let's start with its example. So here we have a graph. Let's check it is acyclic or not. So here we can go from A to C, C to E, from A to D, A to C, but no from C to A. Okay, from B to A, B to D, no in degree to B. So that is a cyclic and directed graph. So we can apply our DFS based sorting algorithm on this graph. So let's start with our procedure. So first of all, you can select any node in our graph for topological ordering. Okay, so here we will select node B. You can also select node A, but we have selected node B here. So we have selected node B and we will put into our stack. With the stack method we are going to follow this DFS based topological sort. So as you all know that from B, DFS says that first search says find its adjacent vertices and follow any one unvisited node. So from B we have two vertices A and D. We will select A, so we will put A into our stack. Now from A we have two adjacent vertices C and D, so we have to select any one vertex from it. So we have selected C, so we will put C into our stack. DFS, you all know that what is DFS algorithm is. So from C we have adjacent vertices only E here, because D is of in degree, so D is not adjacent vertices of C, but E is adjacent vertices of C, because we can go from C to E. So we will put E into our stack here. Now we will check for E. So no unvisited node from E here. So we will delete the E. After deleting E, we will pop E and put into our storage. We will store our deleted, or we can say our popped element. So here E is deleted first, so we will save E here. After deleting E, we will go back to the C. So any unvisited node from C remaining? No unvisited node from C. So we will delete C again. So our values will be E and C, and after it we will go back to the A. Now from A, any unvisited node is available? Yes, D is unvisited node from A, so we will put D into our stack. Okay, so now we will go to the D. So from D, any unvisited node available? We can go from D to C and D to E, but C and E both are visited node, so no unvisited node available from the D. So we will delete the D, we will put here. After D, we will go back to the A. Any unvisited node available from A? C, D all are visited nodes, so no unvisited node available. So we will delete the A from here and we will put here, and we will go back to the B, and after in last step we will delete the B. So B will be our last value. So this is the pop-off content of our stack E, C, D, E, A and B. If we reverse this content, then we will get our topological sort of DFS based algorithm. Means reverse will be B, A, D, C and E. So B, A, D, C, E is the DFS based topological sort of this directed acyclic graph. Okay, so this is the way, this is the method you can follow and find the topological sort by using DFS based algorithm. Again I'm repeating, one graph may have many topological order, so this is not only method. You can start from A and you will get another topological sort ordered. So you can start with any node in our graph and you will get another topological sort order that will be based on the your starting node, or we can say a source node. Okay, so this thing you will have to keep in mind. One graph may have many topological order. Now next example is here. We have to apply DFS based algorithm to solve topological sorting problem for this graph. So you will have to find topological sorting for this graph. Okay, next example, we have to apply DFS based algorithm to solve topological sorting. So this is the graph. So in this graph, observe one thing, that we can go from A to B, B to C, C to D, D to G, G to E and E to A again. So this is a node DAG, means directed acyclic graph. This is a cyclic graph. So as our definition says, on cyclic graph we cannot apply any topological sorting. Here we have a cycle A to B, C, D, G, E to again A. So this is a cyclic graph, so we cannot apply any sorting on it. Next is source removal algorithm. So in source removal algorithm, very simple and very basic method. This is a source removal algorithm. This is a direct implementation of decrease and conquer method. Follow are the steps to follow for sorting of our topological sort of any graph. First step says, from a given graph find a vertex with no incoming degrees. We have already studied in previous lectures that what is in degrees and what is out degrees of any vertex. Delete it along with all edge outgoing from it. If there are more than one, such vertices are break and tie randomly. Note the vertices that are deleted. All these recorded vertices give topologically sorted list. Okay, so this is very simple. We will learn this by examples. Here we have first example. We have same graph that we have followed in our previous example. Here A to C, C to E, A to D, B to D, B to A. So no cycle is happening here. So this is a directed acyclic graph. Then we can apply our sorting method on this. So this method says we have to find it out all the out degrees, okay. So here we have written that with all the edge outgoing from it, if there are more than such vertices, break the tie randomly. Okay, so here out degrees from B, out degrees from A, out degrees from D, and out degrees from C, and no out degrees from the E. Okay, so let's write in degrees of all the nodes. Here B have no in degrees, means 0. A have 1 in degrees, here 1 is coming here. Here from C 1 and 2 in degrees, here D 1 and 2 in degrees, and here E 1 and 2 in degrees. Okay, so we have to select that vertex which in degree is 0. So here in our graph B has in degree 0. So we will delete this B and its edges. Note that we will delete the B and all the edges of B. So here B is deleted and also edges of B are deleted. So our remaining graph is here, and we have to store that delete the vertices. So we have stored B here, and our graph, remaining graph, is here. Again for this we have to find in degrees. So for A in degrees is 0, for C in degrees is 2, for D in degrees is 1, for E in degrees is 2. Again find out the node who have in degree 0 and delete that node and also edges of that node. So here A has in degree of 0, so we have to delete the A, we have to store A, and also we have to delete the edges of A. Okay, so we have delete the A and also edges of A. In next step we have to again find out the in degrees of all the nodes. So for C in degrees is 1, for D in degree is 0, and for E in degrees is 2. So from this graph we have to delete that node who has in degree 0. So here D has in degree 0, so we will delete the D, we will store it, and also we will delete the edges of D. So our remaining graph is C2E. Find out in degrees for all the vertices. C has in degree of 0 and E has in degree of 1. So again we will delete the node C with in degree 0, also delete its edges. So we will store C into our list. Now remaining vertex is E. So here no in degrees, so in degrees is 0, and no edges available, so no worry about it. So after it we will delete the E and we will store it again. So this will be our topological sort by method of source removal algorithm. Okay, so this is very simple method. Just you have to do is find the in degrees of all the nodes, delete the node who have in degree 0, and repeat this process up to the last vertex. Okay, so this is it. This is the example that you have to solve by a source removal algorithm. Okay, so this is it for today's lecture. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you, friends.